Before I start, I would like to introduce myself. I'm Owais, a research scholar, a Prime Minister Research Fellow in the Department of Electrical Engineering, Aligarh Muslim University. I will be holding the session tutorial sessions every week at the same time, 6 to 8, and about the subject smart grid basics to the advanced technologies. And the instructor of this course is Professor N.P. Patti and Professor Premlata Jena. This is the tutorial session first. So just a second. We will start over here. Okay. So now coming toward the topic. So as you have, I assume that you have already gone through the video lectures of this week one, and assuming that you have studied and got some, have some understanding about the topic. So what I will do here over is I will be holding the tutorial sessions. In this tutorial session, what we will do, I will do a recap of the week learning, what you have learned. I will just recap over here and then solve some assignment questions which you have which you have been seeing in the NPTEL portal. Okay, I will be doing that. People are coming. I have a request to all of you. Join early, okay? Because if I share my screen and start teaching, then it is very difficult for me to go over there again, accept the people. So always come early so that the teaching session should be start at the right time, just like this. See? Now I have to accept every one of them. Okay. So next week, from the next week, do not get late. Okay. Come early around 5-10 minutes before that. So it will be easier for me and you also to learn over here. So now it will be quite problematic. If I go on to sharing the screen, then people will come and start. I have to admit them all. I think hopefully no one else come up again. Okay. Now the first of the you have studied over here is the what is the electrical grid in the lectures. Now what is the electrical grid? It is a network of a synchronized powers which provides energy to the consumers and they are connected by the transmission lines. And after the transmission line, they are also connected to the distribution line and operated by one or more control centers. This is a basic, how you can say, a bold definition of any electrical grid. Now, what we know that whenever we talk about electrical grid, it is you can see that there are various things. There are generation stations. There will be transmission lines, and there will be transformers. They will either step up or down the voltage supply, and there will be different types of load. And the transmissions will be mostly either EHV or HVDC. These are generally two types of transmission. Okay. So now I have to again accept all these people. I will request all of you from the next class do come early. Okay. This will be quite problematic. Now what happens here is this. This is the generating station. Okay. This is the generating station. And the power here which is generated is transmitted through these lines and depending upon the step down supply which supply we need the step down transformer is installed over here and it gives and there are three types of load are connected. The primary one, the primary customer, which needs the supply of 11 kV to 6 volt, and there will be secondary customer which have the 400 watt supply. Now the customers which are connected to these 33 submission sub-transmission customer, and these are another set of customers. So you can clearly see that this electrical grid is divided into three parts. First is the generation, second is the transmission, and the third is the distribution. And the distribution is generally like EHV, AC. These are either of 800 by 765 kVs or around 400 kilovolts or maybe around 220 kVs. And the commonly which are used from HVDC lines, these are generally of 500 kVs. Okay. Now coming to to what the different component of the generation, because generation have various components like this is the components of the generation mainly of thermal, hydro based on water, nuclear based on the nuclear energy. And there is nowadays there is new technology is coming which is renewable based energy sources. These are new types of energy sources which are coming in nowadays, and their numbers are increasing very rapidly. And the main reason toward this is what the main reason is to reduce GHG emission, to reduce greenhouse gases emission. Okay, this is the main reason over there. Now, as we know that after this, okay, so now what are the renewable sources? So renewable sources generally consist of solar, most probably in the Indian scenario, solar, wind, and biomass. These are the most, what we can say are these are the most renowned. Now, solar has been given a great backing by our Indian government. The reason because this, the India in India there is adequate amount of solar radiation available. Adequate amount of solar radiations available, and this is like a free source of energy. You just have to install a solar panels over there, and you can harness this energy and store it and use it for your purposes. What it will do here is this: it will it will reduce the burden on the conventional grid, because if your what I can say is if your demand is previously it is only supplied with the conventional base. Now it can also be supplied by renewable energy sources. So what happens here is this: due to reduction of the demand application by the conventional sources, what happens here? The burden, the GHG emission, the fossil fuel burning gets reduced, and we move toward more cleaner and a more cleaner type of economy. Now, after this, this is the transmission which I have just explained about it. It has been done by HVAC, high voltage AC, high voltage DC, and then the distribution. There are and after that there are consumers, because there will be consumers like industrial which require three-phase supply, commercial and domestic generally require single or double phase. So this is basically a component, or you can say the basic layout of a grid, an electrical grid. This is how electrical grid generally layouts. Now coming toward the evolution of the grid, actually, before I talk about the Indian grid, I like to talk about the history of the power grid. So Let me explain it. Okay. So generally, what happens here is that what happens here is that history of power grid. I will discuss here about history of power grid. If this is if not visible, my right handwriting, you can message. Okay, then I will increase the font. Before I write over here, I want to know about from you whether it is visible or not. Write in the chat box, please. Is it visible to all of you? Okay, okay. Okay. Now I will proceed further. So now what happened here is this: the history of the power grid. Actually, Thomas Edison is generally regarded as the father of the direct current, or you can see that DC. Okay, perhaps created the DC technology. But there is another person known as Nikola Tesla. Nikola Tesla. He is generally known as the father of AC because he has created, found the technology of alternating current. So there are two distribution systems, a DC distribution system and an AC distribution system. So now what happens here is this: due to a lower cost and higher efficiency, due to lower cost and higher efficiency over a long distance. Because what happens here is this: generation, the way the electricity is generated, it is far, far away from the distribution side, or we can say consumer side. So we have to transmit the electricity over a far length. So that's why, due to this efficiency, due to this reason, AC has been taken as a base for our electrical layout. This is I can say a bold, you know, a bold definition, or I hope here. Okay. Now after that, what happened here is that there comes another person whose name is Adam Beck. Whose name is Adam Beck. He has created the first Ontario, which is in Canada, Ontario electrical power system. Now, what happened? He believes that the publicly owned power should become to the people at no cost, and there should be, some, and the government should bear over it. But this is not a feasible solution, because what happened here at the time increases, people will also will increase, and what happened here is the demand will increase. And for the demand to compensate, there need a substantial financial amount. So there should be some fees we should take from the user. So he actually, we can say, in principle, lay out the first electrical power system. Now coming towards After this, now coming toward the Indian grid evolution. Now what happens here in the early 60s? In the early 60s, what happened? The Indian grid regional basis grid management has been started like this. Okay. Now what happens here is this: state grids are connected to the regional grids in this early 60s. Early 60s. Okay. And India has been demarcated into five regions, which are north, east, west, and northeastern and southern region. These five these five regions in which the whole Indian electrical grid has been divided. Now, after quite some time, these both grids are connected to form a eastern grid. And this comes in around 1991 October. Okay, this is I have written over here. Okay, and after in 2006, the north and east grids were interconnected, and only four regional current north, east, western grids are synchronously connecting, forming a central grid, and they operate at a one frequency. Then after this, it comes a 2030. What happened before 2013? There is time come August 2006. Okay, and after this 2030. What happens here is this: the southern region was connected to a central grid in a synchronous mode. It has been commissioned in a Raichur Solapur transmission line, 765 kilowatt, therefore achieving the one grid, one nation frequency. Okay, this is about the Indian the evolution of the Indian grid. Okay, people are coming after half an hour. This is not good. Okay, come once. Now coming to the factors affecting the grid. Actually, what happens here is this. I will tell you about before 1990. Our grid or distribution system, all this is very passive in nature. What do you mean by passive in nature? It was like we have a demand, okay, and by calculating the demand, we install the generation. And before that, generations comes from hydro only, thermal, nuclear. These mainly the generations come from this. But what happens here is that after the advent of the power electronics converters and all these, the integration of renewable energy sources increases. And also one of the main factor for integration of RE is this, that we have to decarbonize our economy. We have to decarbonize our environment. We have to, there are various Paris agreements over there. There are various protocols over there where there are different methods to calculate the carbon credits. Okay, now. So what happened here there after these 90s? What happened here there? RES started to integrate into the electrical grid. So what happens from here is that now the system is not passive; it becomes active, because if any active element is in the grid, the system will become active. What from there? What happens is that there are various factors come to one. Now, one of the factors is this: the RES helps in reducing the demand of electricity without installing any fossil fuel based generations. So what it will achieve our reduction in greenhouse gases, all these decarbonization talk, we can achieve by using renewable based sources of energy sources, and they will help also in the demand of in reducing the demand of electricity. These the first factor is mainly solved by the RES integration, and it also reduces the cost because it is easier to install a renewable base energy source plant in comparison to hydro, thermal, or nuclear. Next, yeah, it is also correspond to the supply shortages. And what happened here is this: as I have said, the generation is over here and the demand is here. So what happened here? It has to travel to a large distance, and I square R losses, or we can say the losses, different types of losses also increases are high over there. But with the help of RES, what did RES do? They can be easily installed nearby to the you can say the demand location where the demand is there. Okay, so it will help in reduction of the losses also. Management of the peak demand. Okay, so sometime here is that sometime in a day there is a low demand curve. Okay, so let's assume the fossil fuel based generations are more capable in delivering this much amount of demand. But whenever there is a peak, there is we have to we have to supply this also. But the problem is that if we supply this from the fossil fuel based plant, then what happens here is that let's say this goes around 4 hours. The need of extra energy only for 4 hours. Then we have to install this much amount capacity of a fossil fuel base just for the 4 hours. This will affect our financial aspect. But if we supply this much amount from a renewable energy based source, it will help not only in our financial aspect but also in the reduction of the emissions. And one of the main thing of the renewable based sources is that they can easily be installed and they can be easily be started and the energy produced can be stored in the batteries. And when the time of the peak management, peak demand comes, we can supply the energy back to the grid. Like we, like in the EVs, when EVs are parked over there, they can use vehicle to grid to supply the extra energy at the time of peak demand. What it will do? It will help the user also because he can sell the extra power to the grid, and also the grid operators will also become happy because they don't need to have to install extra installation of the hydro base or any fossil fuel based plants. Okay, this is I have already talked about integration of EV. Now coming the most important topic nowadays people are researching about. My research area is also EV. So what is integration of EV? Now, as you know, there are various schemes by Indian government or there globally there are voices which say that we have to electrify our transportation, which means that which means that we have to replace conventional mode of transmission like conventional modes of vehicles like fossil petrol based diesel based we should electrify. Now what happens here is that electrification is good. Okay, from one aspect you can see, okay, like what it will do, electrification, it will reduce GHG, it will reduce our dependency on the oil. Okay, yeah, also, so it is a very good thing. But there are certain aspects which people don't understand is then whenever EVs gets integrated to the grid, whenever they are connected to the grid for charging, they have very adverse effect. They have very adverse effects. Like they introduce harmonics. They introduce harmonics. What it also do is they increases the power losses. They increases the voltage variation. Frequency gets fluctuated. Okay, these are the serious effects of integration of EV on a grid. So what from a research point of view, we should not be deterred by these effects. So okay, these are so many effects, so we should not be using it. It's not like that. We will create a solution for these effects so that these effects get nullified and still we can integrate EVs. So I have explained about all these you know the factors which are affecting right now to the grid. Now coming to the a most important topic, smart grid. What is a smart grid? Now what happens here is that what is a smart grid? Actually, a smart grid is nothing. Okay, okay, okay. Just okay. I will. No problem. That's what I asked before that. You were not there.
Hello.
Yeah, yeah, sure.
Sir, can you tell a little more about how the EVs introduce harmonic into the system?
Okay, okay. I will share. I will explain that at the later stage. Okay. Let me first increase the highlight. I think. Just a second. Does any idea how to increase the bright? No. Width. I think. Yeah. I don't understand. Is it visible to you? Who's that guy? Preeti? Is it visible to you? That this
Yes,
side?
sir, it's better. It's better now, sir.
Okay, okay. Just a second. Here I need to. I will try to write in a much bigger font, okay? Then it will help you. Okay, now I have to talk about the smart grid. Okay. Now, what is the term smart grid? It is actually refers to an electricity network that uses the digital and other advanced technologies to monitor, manage the transport of the electricity from all generation sources to meet the varying electricity demand of the users. So, what happened here is this elect smart grid is generally a network which is a as name suggests is intelligent, which is an intelligent network. So what happened? It can do everything about generators, consumers, and efficiently deliver a sustainable and economic and secure electricity supply. So what happened here is this, and smart, you have, I think, already heard about the smart meters. What they do here is this, with the help of the smart meter, there is a two-way communication. Right now, those the meters which they most probably in our household, there is a one-way communication. Okay, one-way communication means it comes in. There is nothing goes out. Okay, so in this way, the smart meter we can as I said, like for example, you have an electric vehicle and you have to do the vehicle to grid. For that, for that you have to calculate how much energy I have supplied, you have supplied, and on what basis you will calculate, the rate at the basis, and you will calculate the cost you have get from by selling your extra energy. So these all are done by the smart meter. This is one aspect of that smart meter which I am talking about. It also what it does, it also facilitate the connection and the operation of generation. Okay, and it also provide the information to the consumers. They see there is a term which is a real time pricing. Okay, so what happens in the European country if someone has an EV? So and it after managing his whole day work, a guy comes toward his home and he has an extra energy has in his vehicle. Now what it will do? He wants to sell to the grid, but at what rate he will sell? This information he will get from his smart meter. So right now, let's say zero point 0.3 dollar per kilowatt. This is the energy rate. So he will wait for the he will he will wait for the time when it will be higher. So he will get the higher amount over there. So these all informations are provided by the smart meters, and it also smart meter sorry smart grid, which is actually, and it also maintains and improves the existing service, and they should work efficient. You know, in a traditional grid, what happens here? This is the big electricity plant. Most of the thing in a traditional grid is centralized or mostly regional. There is a one-way communication. Only the user can do what it can do. It has to payment its bill, whatever it is come over there. Okay, in a passive mode. Now, there is no involvement of this user in the functioning of the grid. He cannot impact it. He cannot reduce the demand whenever, like for example, at times come there is a demand of energy. He cannot supply. This is the traditional grid. Now, but in the smart grid, what happens here is there are renewable energy sources are there like solar, wind, or there are conventionals are also there. There is another now, these grids are generally decentralized. There is not a single centralization. And after that, there is a two-way communication with the user, which we can say a proactive. So sometimes grid needs the energy, he can supply whatever he has. It doesn't mean he has to supply all, but whatever he needs to supply, he has a overall right over his energy, or how much amount of energy he want to supply. This type of grid, which is known as a smart grid. Okay, that's why this is smart and this is not. Now, why do we need a smart grid? One of the thing is this, because in initial days of human civilization, the electricity demand was not too much. As you can see, generally there are light sources we need. There are fans. Okay, but nowadays everything is digitalized, and everything needs energy. And you can look around yourself. You can see there is a substantial number rise in the electricity gadgets around you, okay, in the last decade or so. So what happens here is that the demands has been increasing, and one of the major thing which was in the previous grade was the load centers are very away from the conventional. That's why a smart grid is needed. Now, another one of the thing is that there are large number of interconnection in our grid has been increased due to the renewable energy sources, due to EVs charging, because every now another reason of this is the sometimes like I state, there is a some state which has the extra energy. He can sell towards the energy to any state. So there will be a large number of interconnection, and these interconnection will create large amount of instability. So the control over that is smart grid is very much important. Rapid growth in demand of electricity, power system components are being operated close to the desired limit. More investment is needed, and like the final, which I said, the higher penetration of renewable energy sources. And renewable energy sources have very serious effect. They have intermittency, relay coordination, power quality, and all these things. These things can be easily controlled in a smart grid. Now coming to the electric vehicles. As I have said, there is a wide now there is an increase in EVs rate, and this is due to the consumer preferences, also due to environmental, economical, and technological reasons. Some of the reasons are environmental, as I have already discussed, because we have been saying that we will decarbonize by our economy, or all these things. So in there, the EVs plays a very greater role. Another thing is the government regulation that a cleaner transportation options like this. Like economic factors are out there, because we don't want our dependency on the others. Okay, okay, okay. I am not writing anything. Okay, okay. One, two, three, four. Okay, sorry. See, these are some of the things. As technological advancements are there, improved battery technology, advancement in the battery technologies like this, infrastructure development, because EVs can only be more integrated in the system when there is a charging infrastructure is good. And because if there is no charging infrastructure, I don't think you will go 100 kilometer to charge an EV which has a range of 200 kilometer, because 100 kilometer will get wasted in and all. So charging infrastructure is very very important in the EV. And this is the some of the uh, data which says that EVs are increasing like this from June 23 to June 24. You can find it on the net also. Now coming to the distributed generation, which is also a renewable energy sources. It refers to a power which is directly connected to the distribution network. A solar or electric vehicle charging station is also as a type of a distributed energy sources, and these are generally known as dispersed generation. Why we call it just dispersed generation? Because in an electrical grid, they can be anywhere. They can be anywhere depending upon the situation. In this region, there is more solar radiation, so solar will be over here. Like in this region, there is more wind power, so wind type energy resources will be there. And in some areas there is biomass, like these. So biomass energy resources will be preferred. Okay, Hindi and English both. I hope there will be people who don't understand Hindi. That's why I'm going fully English. Spoken Q. Vivek Jadhav. Yes. Vivek Jadhav. Yes. What do you want to say? क्या कहना चाह रहे हैं आप? People are coming so much late. What happened here? This is Sharwan. This is not the right time to come to a class. Okay. Okay. This is an online class. You can join at any time, but it's not a right way. The next time I won't be allowing because it, you know, interrupts so much. So this is how now they are also categorized on the basis of their capacity. Like small scale DG, they ranges from 5 kilowatt to 5 megawatt. Medium ranges from this. Large ranges from this. Okay. Now, what happened here is this, they have, I have already said that they help in reduction of losses, improvement of the power quality, and harmful emissions, less harmful emissions, and reduction in GHG. And they also increase the reliability of the system, because let's say, there is a failure in the conventional transmission system, like conventional sources cannot transmit power. So DGs can, locally provide the transmission of power to you, and they have also low operating cost and help in the peak saving. That's why these are done. Now there are some definitions of a smart grid, and there are various institutes. They have individually defined that what is the definition of a smart grid is. So, for example, NIST, National Institute of Standard and Technology, they have defined smart grid is a modernized electrical grid which uses information and communication technology to gather and act and information such as information about the behaviors of suppliers and consumers in an automated fashion. What it will help in? It will help to improve the efficiency, reliability, economics, and sustainability of the production and distribution and electricity. This is the most important thing, which because whenever you go for any interview, any Viva Voice, they will ask about whether you have done a course on a smart grid. They will ask you about definitions. So you can say about them there as per National Institute of Standard Technology, the definition of standard. This is, and there is an International Electrotechnical Commission which also define the smart grid, which can integrate intelligently integrate the action, यानी कि एक इंटेलिजेंट तरीके से एक्शंस को इंटीग्रेट करता है. कौन से किन किन के ऊपर इंटीग्रेट करता है? जनरेटर्स, कंज्यूमर्स, और in order to effectively deliver sustainable economic and secure electricity supplies. Okay. US Department has also defined the smart grid is an electrical grid which includes variety of operational and energy measures, including smart meters, smart appliances, renewable sources, and energy efficient sources. Okay. Now, European technology platform has also applied more or less what is the thing behind these definitions is that they are they are generally defining the smart grid in their own way, but the main if we take a conclusion from these, it will all direct toward us one thing, which is the smart electricity conservation, so that they can, our the operations of the grid, the operations of the grid is efficient, sustainable with a lower losses and higher level of quality and security of supply. International Energy IA. So these are the definition. I think you should learn from it and don't forget about it, because in any exam or any job interview they can ask you about it, about what are the the definition. If you know any one of them, you can clearly say about what are the these are things. Now let me go. Okay. Now coming toward the standard, because there are various standards. Uh, like, okay, before that I will show you about the differences between an existing grid and a smart grid, a point wise thing. Okay. This existing grid is electrical plus mechanical. This is fully digital. This is fully digital. There is one way communication. There is two-way communication. Okay. And there is centralized generation. There it is. What it is? Decentral, decentralized. Okay. And because it is a one way and a more electrical and mechanical, sensors are limited. But here, central sensors in every aspect there is sensor. You can see sensors throughout. हर जगह सेंसर ही सेंसर. ओके. यहाँ पे क्या होता है? लिमिटेड कंट्रोल होगा. ओके. देयर विल बी लिमिटेड कंट्रोल, बट हियर इट इज per pervasive control. Everything is under the smart grid control. Okay. If there is outage in the existing grid, there has to be a manual restoration, because someone will go and restore our lines. But in a smart grid, there will be self healing. It will automatically heal in himself. Healing means restoration, so self restoration like this. Okay, this is the broad. You should write it down. Okay, okay. This is the broad differences between a smart and a existing grid. Okay. Now coming to the standards. So there are various standards. Let me write it down. Right. Okay. People are coming after 1 hour. It's the online class. Okay, there are various standards are written over here for the smart grid. These standards ensure that they are compatible and interchangeable, safe for individuals and public, and safe and friendly for the environment. These are actually the rules and guidelines and definition of various things. Okay, ability and it also helps to improve the economic performance. Now, classification of smart grid. Classification of smart grid. What are the various classifications of any smart grid are for the standard basically? First is the classification based on the cyber security. Based on the cyber security. And there are various standards are here like NISTR 762. Recommendation for a smart grid. Okay, okay, I will give it. Okay, no problem. I will give it to you. That's not it. Because I don't think you need to go other than this NPTEL lecture. It is very self-sufficient and it helps in all the aspects. But if still you want, that's not a problem. I will give you some. Okay. So the standard depends upon the class upon the cyber security standard. There are NISTR 7628, IEC 62351, and ISO 27001. Based on the communication standard means how a smart grid communicates. There are various standards to it. These are EEE 203, IEC 61850, and other classification is based on the DER, means renewable energy based connection. How the renewable energy sources are connected to any grid, and these are several connections. I will explain it later. And after this, there comes the wide area situation awareness because in a smart grid, there is a term which is known as wide area monitoring. There are several standard to these. These you should know, write it down in your copy. Okay. Now coming to the 6140. Now, what it is? It is a part of an international. This standard is given by IEC that focuses on communication for monitoring and control of the wind power plant. The standard is crucial for ensuring the interoperability between various systems and components used in the projects. Now, there are various. Now, this is the one standard. This 25, tells about the part number. It provides the guideline for the information exchange between the SCADA and the various external systems like wind turbine control. It also ensures that the data from different manufacturers and systems can be shared and used efficiently. That is the most important benefit of any standard. It has, and what it does, it actually universalize everything. And it is divided into different parts. 25 1 for monitoring, 25 2 for you know information and model exchange. Okay, let me show you also. And 25 1 is for okay, 25 2 for information models, information exchange. You should know, it is not recommended to buy hard it, but you should know about it, what this standard comes do about it. Okay. Now, another standard is from IEC 6185. It is a part of a 16185 series. It actually defines the communication network for a power utility information automation. It actually specific needs of DER integration. Now, what happens here is this The purpose of this is to provide a standardized approach for modeling and communication of the renewable sources. Because whenever a renewable source is integrated into a smart grid, there should be a communication channel. How it should communicate with other devices. So this standard ensures that. It also shares the information model required the operation of various DER systems like photovoltaic system, wind turbine, battery storages, and another system is of IEEE, which is IEEE 1588. It is actually a precision time protocol, a standard for precision time synchronization clock in an environment. So what happens here in this? In a smart grid, there are various data acquisition devices like SCADA and PMU, phasor measurement unit, and these all these units, they gather the data on the based on the time, because at what time they gather data, because whenever there is an energy operator, he wants to analyze the data, he should know at what time this data is calculated. For timing of the data, the protocol, we should know for the precise timing synchronization of the cloud in an environment. That's why this protocol helps in that. It helps for application requiring high precision timing coordination across the distribution system. There are two are high precision time synchronization, and another is a network system. So now up to this, I have almost almost recapped the last week's video lectures. Okay, what has been taught on the NPTL and what it is. Now next part of this is the assignment and solution. Okay, so I will actually what I will do here. I will reduce it from this point and will ask you what are the solution to these questions. Okay, so now coming to this, the first assignment and solution is, first question is, when was the one nation one grid one frequency achieved? Okay, these are the options: A, October 1981; B, March 2003; C, August 2006; and D, December 2013. Now, I will wait for a second and you should answer this, okay, in the chat box. I will see over there. Then I will explain it what is the answer of this, okay. So, write in the chat box the answer of this. I am waiting for this answer. I hope everyone who has joined is available here. No answer is coming. क्या लगा के मोबाइल सब चले गए हैं क्या? कोई है नहीं क्या?
Yes, sir. Sir, it is D, December 2013.
Okay. Uh, Other anyone else? No one. इसका तो आंसर दे ही सकते हैं, इसका तो मैंने आंसर भी दिखा दिया है. तब भी नहीं दे पा रहे आप लोग आंसर. ओनली वन स्टूडेंट हैज गिवन द आंसर.
So people are answering the chat box.
Okay, okay, then let just, oh yes, okay. I think I should see the chat box. Yes, 30, 30. Okay, okay. Yes, the answer is one nation, one frequency is achieved in 2030. I have already explained in this, when the southern region was connected in a synchronous mode, Raichur Solapur transmission line on 31st December 2013, thereby achieving one nation, one grid frequency. Okay. Now the next question is, just a second, I will. Okay. The next question is, which type of the following is the most environmentally friendly type of a distributed generations? A. Reciprocating engine, gas turbine, fuel cell, and geothermal. You can unmute yourself and answer. Okay. I want answer, one by one, because if I go towards the chat, it will reveal the answer. Okay. I will showing the answer over here. Let me
Fuel
see
cell.
who. Okay. Let me see who have answered this answer. Okay. Question.
Fuel cell, sir.
Yeah. Oh, just a second. Just a second. I will share a screen in a minute. In a minute, I will share a screen. Is it visible to you all of? The answer is a fuel cell. Because fuel cell is one of the most environmentally friendly generation and is extremely quiet. Because there are various DGs are given, they are also cleaner. But we have asked for the most environmentally. So that's why the fuel cell is the right answer. Okay. Does any have a problem about this? So the next question is, new requirement for bulk generation domain includes. What does it include? First option is greenhouse gaseous emission, increases in renewable energy. Third option is provision of a storage to manage the variability of the renewable generation. What is the answer? Write in the chat box.
Sir, please show the question, sir.
Yeah.
So still have a second question only, sir. It's showing only second question. Question number
It
two only it's showing now.
okay. Now is it showing
Yes, sir. Yes, sir. Yes, sir.
question number
The
three?
third
Is it
question is
showing
yes,
everyone
sir.
too?
Question number three is not visible.
Not visible. Okay. What happened?
Now in yeah, this
Okay. Well. Okay. Wait. 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 It will do it. Stop the writing. I will re-present. Okay. Don't worry. Is it visible to all of you?
No, sir. No,
yes,
no.
sir.
No? Yes. So what is the answer?
Yes, now.
Can you tell me what is the new requirement for the bulk generation domain include?
All of this, sir.
Okay. Anyone else?
For all of this, sir.
All of you. Okay, yes. All of these is a requirement, which is the correct option actually, not the requirement. It is the correct option. So, what bulk generation domain include? Increase in the renewable energy sources. Yes, we want to increase the renewable energy sources. Greenhouse gaseous emission control. Of course, we have to we our aim is not right now is to control the emissions, and also provision of storage to manage the variability of the renewable generation. Actually, the renewable generation. is very intermittent in nature. Okay, intermittent in nature is this: its output power increases with the time. So generally, for solar, it generally goes on like this. This is the peak time. This start and end. This is around 11 a.m. to around 2 to 3 p.m. Something like that. And main is around 12 to 1 p.m. So you can see that at the start of the day, radiation is low, so output is not much high. But at the time goes, it will increase. But after the sunset, it will also decrease. This is the intermittency for a day. This is intermittency for a day. Now, same for the wind, because the wind speed is dependent upon on the time on the situation like that. Like it varies time to time. So the problem with the renewable energy sources is that they are very intermittent in nature. Okay, so what? So you cannot say if we need some no some kilowatt hour energy at that time, so it will available at it may or may not be. So that's why there is a provision that we store the renewable energy into the batteries and use whenever the time comes. Who is coming? Listen. Okay. Next is the this is the this is about the information exchange for monitoring and control of the wind power plant. Okay, I think you should know the answer because I just have explained this. So I will directly going toward the answer. IEC 61400
4025.
25. Yes, yes, correct. Yes, sure, nice. Communication for monitoring and control of the wind power plant provides the information exchange for the control between the wind power plant. Okay. Now next is according to IRG, the time synchronization accuracy is up to. There are four options: 0.5, 1, 2, 0.1. Does anyone know about this?
Option B, sir.
Option B. Okay, right. So option B is this. Actually, what is IRB? It is an inter-range instrumentation group. It provides the time code format for taking the precise time synchronization across various systems. Okay, and it has various codes like this: A, B, B, C, D, and each having the different format and specification. But the IGB code is widely used in application where precise time synchronization is critical, such as in telecommunication, power grid, broadcasting, and data acquisition. Okay. Now the next question in advanced metering interface, each meter uses first UDP, Internet Protocol, Transmission Control Protocol, or all of the above. What does it uses?
Sir, all of this above.
All of this above. Okay. 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 Anyone else? Just
Option B, sir.
option B. Okay. So actually, right option is option B. Otherwise, द थिंग इज दैट यहाँ पे ऑप्शन ये भी सही है, ये भी सही है, ये भी सही है. बट क्या होता है ना, जब आईपी यूज कर लेते हैं हम किसी के बारे में, तो उसके अंदर यूडीपी और टीसीपी दोनों आ जाते हैं. It is like a trick question, you know. Each meter in advanced metering uses IP for addressing and routing. अब जब हम कह देते हैं कि कोई IP पे यूज करता है, तो इसका मतलब क्या है कि वो UDP और TCP ऑटोमेटिकली यूज कर रहा है. That's why we cannot say कि ये UDP सही है. UDP तो एक पार्ट है उसका, सही है, लेकिन C उसमें मिस आउट हो जाता है. लेकिन हम TCP को करेंगे तो हम मोस्ट करेक्ट ऑप्शन क्या होगा? internet protocol is the most correct one. However, choice of depends also be depending upon this. Okay. Now, this is the question. Monitors the break the feeder circuit if current exceeds the threshold.
Option A, sir, reclosers.
Recloser. Anyone else?
Option A, sir.
Option. Okay. So it is very simple. You have already studied in your bachelor courses if you are bachelor on, in a course. Okay, reclosers are protective devices used in electrical distribution system. They actually monitor and break the feeder circuit if the current exceed a predefined value and automatically closes after an interruption, allowing the temporary fault to clear and restoring power without any manual intervention. If the fault persists, अगर fault रहता है थोड़ी देर बाद, will open and close a number of times before staying open to isolate. अब क्या होता है कि fault जैसे ही recloser बंद करता है सर्किट फिर से fault हो जाता है, फिर open होगा, फिर काफी बार होगा, तो उसकी वैल्यू सेट कर देते हैं कुछ इतनी वैल्यू के बाद फिर क्या करेगा ये ओपन ही रहेगा आइसोलेट कर देगा सर्किट इसको क्या लगेगा कि सर्किट में देयर इज अ सीरियस फॉल्ट इन दिस एंड आई शुड बी ओपनिंग now coming which component of SCADA present data to master station
Remote terminal.
remote terminal anyone
Option
else
B.
okay next anyone else
Option A, sir.
option okay DPA is a right option what it does is what DCA does, it acquires the data from the devices with a data communication capabilities via communication ports. डेटा प्रोसेसिंग एप्लीकेशन क्या करता है वो डेटा को प्रेजेंट करता है टू मास्टर स्टेशन और एन ह्यूमन मशीन इंटरफेस बट डेटा ट्रांसलेशनल डेटा ट्रांसलेशनल एप्लीकेशन क्या करता है इट मैनिपुलेट द डेटा बिफोर दे आर प्रेजेंटेड टू द मास्टर और एनी सपोर्ट एट आरटीओ लेवल तो आर दैट्स व्हाई द डीपीए इज द मोस्ट करेक्ट ऑप्शन ओके now tell me about this which of the following is the IEEE standard conformance test procedure for equipment interconnecting distributed resources with electric power system I'm sure you have, if you gone through your, video lectures, you should have known this, what what it does about. Okay.
Option number one, sir.
Option number one. Okay. Anyone else?
Option number B, sir.
Option number. Okay. What it does is option number A. IEEE standard 1547.1. What it does is it it gives the standard procedure about equipment interconnecting distributed resources with electric power system. So what are the others do? 547.3 it does it monitors information exchange and control of the distributed energy sources with the power system. For 47.2 what it does it guides the application of for 547 and IEEE standard for interconnecting resources and this one 1547 it designs and operation and integration of distributed resource island with the electric system power. So, as per the question, the correct answer is A. Now, what is the power range of an industrial load? What are the options? Anyone? Sorry, I might be disconnected. Okay. Does all of you get disconnected? Does all of you get disconnected? Yeah.
Yes, sir.
Okay. Okay.
Yes,
No
yes.
problem.
Yes, sir.
Am I audible to you right now? I will resume at from that question. No problem.
Yes,
Yes, sir.
audible.
Audible? Okay. Okay. Go ahead.
It's audible, sir.
Now I will share my screen. Sorry for that. I don't know what happened. Okay. This is the question we are going on here. Okay. Power range of industrial load is.
Sir, before that we have another one, sir. Eighth question. Already we finished the seventh one. Yeah.
This one. This one. No.
Yes, sir.
Okay. Okay. Wait a second. People are coming. I think. Okay. This one. No.
Yes, sir.
Yes. Okay. Okay. Is it visible to all of you?
Yeah, yeah, visible.
Yeah. So the answer, what I'm talking about, this is. Okay, what I'm talking about this is the answer to this is IEEE standard 1457.1, because the reason behind this is there is no there is a written guidelines like equipment interconnecting distributed energy resources with electric power system. 547.1 does that. For 47.3, what it does, it monitors information exchange and control of the energy resources with electric power. 47.2, what it does, it guides the application for 1547 for interconnecting distributed energy resources. And 47.4, what it does, it designs, operate, and integration of energy resources island system with the electric power system. Now, next question I'm going toward is the power range of an industrial load is. What is the power range of the industrial load? Can anyone answer that?
Sorry, sir.
More than 200. D.
Okay. Yes, yes, yes. The
More
answer
than
is
200
yes,
kilowatt.
yes, yes, yes. Okay, okay, sure. Nice. The answer is greater than 200 kilowatt, less than 220 kilowatt for home, and the range from this 20 to 100 for commercial building and 200 for the industrial. Now, another question is, what is the key features of a smart
Option 3, sir.
Two-way communication. Option
Two-way
three.
two-way
communication, sir.
exactly? Yeah, it's very simple. Two-way communication is the answer to this. The key feature of a smart grid. Now, coming toward what are the benefits of the implementing smart grid technology in the context of a renewable energy integration? So, can anyone answer that before I explain this?
Option port 1, sir.
No
Fourth
one?
one.
Am I audible?
Is a fourth one option.
Option port 1.
Hello?
Yes, sir, you're audible.